OSC is all about the process for end-to-end communication. That process we are learning in the steps of 7 ways. Those are nothing but layers. What are the layers? We have application layer to physical layer. No, application layer, presentation layer, session layer, transport, network, and data link and physical layer. Okay. See, these are the layers. This is the first layer. What about the last layer? Application layer. Okay. See, at layer 1, this device works. At layer 2, switches. This device can understand only MAC address. What about layer 3? Routers or L3 switches, they can understand only L3 address called IP address. And at layer 4, what device works? Most probably firewall. It can able to filter TCP or UDP related services. How many of them new today? Okay. Right. Okay, TCP is a transport protocol, UDP also transport protocol. They will carry services, web service, mail service, file service. Okay, and UDP will carry these services, DNS, DSCP. These services will discuss separate section is there in the IP services. And also, if you want to drop any service under TCP box, you can drop with the help of which device? I can able to filter any services under TCP or under UDP by using which device? Firewall, no? By using firewall, what I can do? I can filter the services. What services? Under TCP services or under UDP services. All these services comes under where? See, we are typing google.com, automatically what will happen? HTTPS will be enabled now. That is a protocol responsible for to open the web page. Clear? That's a background protocol. That protocol will be automatically enabled. That will be happened in application layer. That means all these services for mail service, what is the protocol? For file service, for remote access, telnet and SSH. What is the full form for the UDP? Yeah, you only. You. Yeah, UDP. I told already yesterday. I will ask the questions. Okay. You. User data. Not correct. You. You. And that is not correct. You.
User datagram protocol.
You.
User datagram protocol.
Okay. What is the full form for the HTTP?
Hypertext transport protocol.
SNMP.
Symbol mail transport.
TFTP. I told already. Okay. Okay. UDP is correct. Simply okay. Right, guys. Now we'll see. See all these services, protocols enabled for a particular service. What are the background protocol? There is, it could be HTTP or it could be FTP or it could be telnet or SSH. It could be SNMP. Okay. For SMTP for mails. That means all these protocols, all these services works under which layer? Layer 7. Okay. And what will happen in the presentation layer and session layer? Clear now? See, if you want to transfer some amount from your account to your friend account, what you will do? You will open the net banking, no? Where you will type the net banking? Browser only, no? Correct. No? Then immediately what will happen? It will ask the username and password. Correct now? If you type the username and password is only, you would type only 3 letters only or 4 letters. Automatically what will happen? It will go like a string now. That means what is happening over there? Your password is encrypted. Encrypted means unreadable format. Secure. Clear now? That will be happened in the presentation layer. Not only encryption, it will do encoding also and decoding also. Encryption at source side and decryption at destination side. Encryption means our password is converting into some other like unreadable format. Okay, by using some encryption algorithm. By using some encryption algorithms. What are the encryption algorithms? Encryption algorithms are, one is called DAS, one is called triple DAS, one is called AES. Full forms also you have to write down in internet. Okay, tomorrow I will ask. Okay, and we have some hash algorithm. These are what encryption algorithms. These algorithms can do the encryption for your data or for your passwords. Encryption means what? See, this is your password 1 2 3. This should be converted into, this is a plain text, na? Plain text. Okay, what about the encrypted format means? Like this, dollar @ hash colon, so that means some other unreadable format. How you are getting from plain text to the unreadable format? By means of this protocol, this algorithms only. By means of this algorithms only. Clear now? Even though we can able to convert from unreadable to readable, we can able to break also. We can able to break encrypted passwords or encrypted format passwords. This way, these encryption algorithms are not strong. Okay, these encryption algorithms are not strong. We have to go with the hash algorithms. What algorithms? Hash algorithms will be there. What are the hash algorithms? There are two hash algorithms are there. MD5 and SHA. MD5 and SHA. Message Digest version 5. SHA means secure hash algorithms. Okay. If you take this encrypted format password, if you apply it in the hash algorithms, anything, okay, if you apply it in the SHA or MD5, you will get the output that is called hash value. You will get what? Hash value. That is more powerful. We can't able to decrypt. Clear now? That's what I want to do. Whatever the encrypted password you will get, that password again you need to apply in the which algorithm? Hash algorithms. It could be MD5 or it could be SHA. You will get the hash value. That could be more critical to decrypt. Impossible actually. Okay. Clear now? What will happen here? Encryption and decryption, and encoding and decoding. What do you mean by encoding and decoding? See, this is my PC. Correct now? I am here. Okay. I can understand binary or what? I can't understand binary. This guy will understand what? Binary. I can understand ABCD. Correct now? That ABCD, this guy can't understand. ABCD for human being purpose. Okay. I am typing ABCD. That has been converted into mission understanding format. Means binary. That will be done by, this is called encoding. Okay, again converting from that format to this format, that's called decoding. That will be happen in the presentation later. Okay, there are two standards are there. One is called American standard. That name I forget. One is called ASCII and one is called EBCD. EBCID. Correct? Na? Anybody knows? ASCII is the no American Standard Code Information Interchange. Correct? Na? I don't know exactly. Let me check it in the internet. Okay. Full form I don't know. Okay, I forgot actually. Google it. ASCII. Yes. ASCII. American Standard Code for Information Interchange. Code for Information Interchange. Okay, and one more is there now. That is called FCD. EBCID. Okay. DIC. Okay. Okay. This one. Extended Binary Coded Decimal Interchange interchange code. Clear now? These are the okay codings. Okay, by using these codings only, okay, this translation will happen. Human understanding to the mission understanding to the human understanding. That means ABCD to the binary, that is called encoding, and binary to the ABCD, that is called decoding. Then only we can able to understand. Now this translation is required. Simply you are typing like a ABCD, mission will tell I can't understand your language. Then how we will communicate? Correct or not? Okay, that translation is required, encoding and decoding. Then only we can able to communicate with the missions. Okay, now what are those? One is called ASCII, one is called what? FCD. FCD. Okay, extended binary coded decimal interchange code. Okay. Now, not only this, guys, and also there is some task also will function also will happen over there, and it will define the data formats. Clear now? If you want to download any resume, okay, that resume will be always which format? .doc. Correct now? What about the next? Test.txt, image .png, jpg, so on so on. These formats also defined in which layer? In this layer. Okay, data formats will be decided in which layer? Presentation layer. Okay, data formats has been declared in this layer. It will define the data formats like .mp4, .mp3, all are what formats for a particular data. Okay, that these standards, these formats will be same now. If your device will be a Linux or maybe you install with the Windows or whatever it is, Mac OS, this format will be same. Will be changed? No, right? That means there are some standard formats will be declared at presentation layer for any operating system. Okay, data formats will be defined in which layer? Presentation. Clear now? That is all about the presentation layer. Okay. Now, what are the major functions of presentation layer? Encoding and decoding, encryption and decryption, and data standards will be defined in this layer. Data standards, that means formats. Okay. Now, what will happen in the section layer? Oh, sorry, I need to explain my scenario, right? Username, password. That password will be encrypted now. Append in the presentation. Now, once you give the password and enter, immediately it will open the your account details. It will take 2 second time. 2 second now. In that 2 second, what will happen? It will create the logical connection from here to your ICICI bank server. Okay, it will create the session. For the purpose, it will take maybe 1 second or 2 seconds based on your internet speed. Correct now? Okay. And also once it will create a session from your laptop to the ICICI bank. Okay. One section is created. Then what will happen? You can able to transfer the money. You will get the acknowledgement now. Correct? That acknowledgement will be done by at which layer? Transportation purpose. What protocol is there? Okay. And now we're transferring money. Okay. That means once you open the net banking, automatically which protocol will be enabled? HTTPS now. That means who will carry this service? App service? TCP or UTP? TCP. Correct now? TCP will give the acknowledgement. Whatever the data, suppose not only money transfer here, if you're sending any data, guys, if you're sending any data, suppose you are sending the A, B, C, D. Okay. Before sending this data, okay, if you send this data and this guy will should give the reply. How this reply is coming? That means this guy is telling I received the ABCD. How you are getting this response? Because of TCP. Because of TCP. There is some difference will be the TCP and UDP will discuss in tomorrow or day after tomorrow. Okay. Next, after that, this server is belong to what location? Clear now? We are accessing this server. This server is from which location? I am in Bangalore. I am where? Wait, in Bangalore. Maybe server should be in the Bangalore or Chennai or Delhi or Mumbai or Pune. Correct now? That means that network location will be identified in which layer? Network layer. Network location. Not exactly location. Network ID. Network ID means that server belong to what? Network ID. That is belong to Bangalore network ID as Chennai network ID. Okay. That means we are accessing that server from which network? Network means imagine like a Bangalore, Chennai, Pune, like that. Okay. We are accessing this is also from Bangalore. Okay. In that Bangalore, how many servers will be there? I say maybe imagine there are 20 servers are there. Correct now? In that there are 20 servers. This is a Bangalore branch. How many servers over there? 20 servers are there. Imagine. Out of this 20 server, oh sorry, let me decrease this. Out of these 20 servers, Okay, imagine. Okay, some servers are there. The network identification will be done by that means network identification will be done by network layer, and in that network specific, maybe you are accessing this one, this server or this server, we don't know. Okay, in that network specific device identification will be done by data link layer. Clear now? The network identification will be done in which layer? Network layer, and in that network which server you are accessing, that is done by data link layer. That means specific device means what are the MAC address of this device. Correct now? Network identification is done by layer 3, and in that network specific device identification will be done by data link layer with the help of MAC address of the server. Clear now? Then via cable request will go, reply will come. That will be done by physical layer. This is all about the explanation. If you take one example in interview also, they will ask, okay, explain the OSA reference model from top to bottom or bottom to top, and 2 minutes only, not more than 2 minutes. If you explain this one with any real-time scenario, clear na? Maximum 40% you selected. First question this only. Clear na? First question this only. Next they will ask about the port number, that one, this one. Okay. If your first question is not impressed, then within 2 or 3 minutes you will be, they will call like they will tell like we will call you later. Clear now? Interview should be at least 40 to 50 minutes. That means you almost selected. Correct now? Almost selected. Okay. That means this explanation should be less than 2 minutes. Okay. How to explain less than 2 minutes, guys? Take example. Okay. Yes. Okay. I am the you are the interview guy. I am the student. Okay. What? How to explain? They will ask. Explain the OSA reference model from top to bottom. Yes. Sir, I want to transfer the some account, some money from my account to my friend account. First of all, I will open the browser. In the browser, I will type the online ICICI net banking. Automatically, that will be happen in this layer. Then I will give the username and password. The password is encrypted here. Next is it will display the account details after some time. That means section will be created. Then I will transfer the money. I will get the acknowledgement by means of TCP. Next, the server is belong to what location, that will be done by this one. In that location, exact device identification done by this layer, and also a cable. It could be anything, media. It could be wireless, or it could be wired, fiber optic, or Ethernet, whatever it is, done by this one. How much time? Huh? 40 seconds, sir. Really? That means they will give 2 minutes. Don't worry. Okay, they will give 2 minutes. See, take this example only and explain to them. Sometimes they will ask rare. Explain the OSA from bottom to top. Maximum they won't ask like this. They will ask only top to bottom only. If they will ask like this, what is your answer? Your answer should be, this is my PC and this is my Google server. Here is the internet is there. Okay, here is the internet is there. That means from here to here, how the communication process will happen. Or else this is a some file server. Okay, you are uploading some files. Okay, you are uploading some files. Okay, or else web communication. Okay, this is a Google is a web server now. Now what will happen here? You need to type the, here what will type? www.google.com. Again it will come application layer now. Correct or not? How you can explain? Simple, guys. Here is physical layer means my PCs, all PCs connected with the switch via cable. Cable is a layer 1, switch is a layer 2. Then from day to router, router is a layer 3. From day to ISP, ISP to internet. In internet we have a Google server. This is called layer 1. This is called layer 2. This is called layer 3. Okay. What about here is a link is there now. That means in the internet what will happen? Whatever your data will be there, that will be secure. But before that, we need to transfer our data. That will be done by transport layer. But here is whatever explanation, we have to take it from top to bottom only. You will get the proper answer. Correct now? Whatever the requirement, that requirement should be have to type in the browser only. No? Correct or not? Okay. Correct or not? Okay. We can explain like that also, but this is not a proper way. They will ask maximum From where to where?
Top to bottom.
Top to bottom only. Clear na? Top to bottom only. Clear na guys? All these services works under which layer? Application layer. Okay. Clear na? Here is what will happen?
Creating a sessions.
Yeah. Creating the session and maintain the section and also terminate the session. Create the section, maintain the section and terminate the session. Create, maintain and terminate. Create means you are downloading some data. Before downloading, what will happen? From your PC to your file server, okay, session will be created. You are downloading some data, okay. It will take 5 minutes time. Up to 5 minutes, the session will be there, still maintained by that session layer. Once 5 minutes is done, your downloading is done, then automatically terminate the session. Clear now? Create the session, maintain the session and terminate the session. Clear now? That you need to remember guys. Now we'll discuss about the next slide. That is called, see, this is important now. PDU, protocol data units. What is this? PDU means it's all about the format guys. Which format means example language. In Karnataka we will understand Kannada, no? Okay. In Andhra, Telugu. That is the format. Okay, they can understand. In Tamil Nadu, Tamil. In Kerala, Kerala. Okay, Malayalam. Okay, and UP, Hindi, most probably. If you go to the UP, you will speak in Telugu. Is it good? They can't understand. Okay, every state has their own standards, formats. Okay, they can understand. Correct. Now here also every layer will understand some format. That format name is called protocol data units. What is that? Protocol data units. Okay. What format your layer 4 will understand? What format your layer 3 will understand? What format your layer 2 will understand? Clear now? What format your layer 7, 5, 6 will understand? Okay. See guys, from layer 7 to layer 5, that format is called data. Format is called what? Which data? It could be web data, mail data, file data, or remote access data. Web data means what? It could be HTTP data. Mail data means it could be SMTP data. File data means FTP data. Remote access means SSH or telnet data. Correct now? Okay. Now, file data. This is your file. Okay. Suppose my file consists of some data. That could be this A, B, C, D. This is my data. Okay. Okay. This is called my data. Example I'm writing over there. I written what? Some example. This is my data. File data. Okay. It as a, imagine 4 GB data. How much? 4 GB. Okay. That is called 4 GB is called data. What will happen at the transport layer? At once this data will be entered into the TCP box or UDP box. No. These services, all services carried by TCP box only. Correct now? Now, once these services, this data will be entered into the TCP box. What TCP box will do? It will transport. These are what transport protocols. Before transporting, before uploading from my PC to my file server, before uploading, okay, what will happen? Your TCP will take the data. It will convert into small pieces. That piece is called segment. Clear now? Segment means what? Piece of data. That means some bytes. Correct now? This is 4 GB now. I'm converted into 1 GB, 1 GB. That means segment is what? Group of bytes. Clear now? That will be done by TCP. That's why TCP or UDP segments. That means segment is a format at layer 4 guys. Okay. At layer 4, what is the format? Segment. Clear now? At layer 7 to 5, data. It could be web data, mail data, file data, like that. Now, one segment will come. Segment will be carried by, it will be entered into the which box? See, data will be entered into the TCP or UDP box. These two boxes will be entered into the IP box now. Then that is called packet. That means IP will carry TCP box and UDP box, and every box will carry services. That means lower layer will carry upper layer information, and this layer will carry upper layer information. That you need to understand. Every layer will carry upper layer information. Clear now? Every layer will carry upper layer information. That means IP is carrying the TCP UDP boxes, and each box will carry upper layer information. That could be F service or mailer, file, or DNS, whatever it is. Okay. Now this Ethernet is a layer 2 protocol. Actually, I told now. Okay. He will carry upper layer information. That is called what? IP. Then that is called it is what? Ethernet frame. See, at layer 2, the PDU name is called Ethernet frame. At layer 1, simple frame or bits or signal. Clear now? Bits, signals, frames, all are same. Bits, signals, frames, all are what? Same. Okay. Now write down, guys, all these PDUs. For the layer 2, at layer 2, the PDU name is called this. Sorry, layer 7 to layer 5. At layer 4, segments. At layer 3, packet. At layer 2, Ethernet frames. Full write down. At layer 1, frames or bits or signals. Okay. Write down, please. Now one thing understand, guys. Here we have a, see, for every layer we have a, for every layer we have a data formats. Okay. At layer 7 we have a services. How to identify the services? Clear now? See, this is my server. Okay. Okay. In the server, all services are running. Web service running, mail service running, file service, and everything, remote access. Suppose you are accessing website, web page, web request. From your side, you are accessing mail request, file request, remote access. How my device will understand? Some guys is asking about the web request. He is asking about the mail request, or he is asking about the file request. My device can understand, server can understand based on the port number. Server can understand based on the port number. Okay. There are port numbers will be there for every service as a port number. The port numbers will be starting from 0 to 65,535, and from 0 to 1023 are the reserved ports. That means all these ports are reserved for already for HTTP, HTTPS, SMTP, FTP, Telnet, all these things. Okay, these ports will be in between 0 to 1023. These are what? Reserved ports. Okay, what are the total ports? Sorry, range of the ports 0 to 65,535. Okay, in that up to 1023 already reserved. From 1024 onwards, not reserved. Those are what? Unreserved ports or open ports or ephemeral ports. So many names are there. Okay, and this is the reserved ports or well-known ports. Names. Okay, reserved ports or well-known ports. These are the unreserved ports or open ports or ephemeral ports. Okay, clear now? This is all about the ports. Okay, for every service as a port number. Can you see there? For a web request, what the background protocol? HTTP. For the port number 80. Why before I mentioned like a TCP 80? 80 is a port number for HTTP. Okay, this HTTP will be carried by which box? TCP. That means TCP will carry port number 80. That means HTTP. And TCP will carry port number 25. 25 means port number for SMTP. TCP will carry 21. That means FTP. TCP will carry 23. 23 means it will carry Telnet. TCP 22 means 22 is a port number for SSH. Clear now? For every service, we can identify with the help of the device can identify based on the port number only. Okay, this is my PC and this is my server. This MAC address is A, this MAC address is B, and IP address is 1.1, IP address is 1.2. Clear now? And in that server, all services are there. Okay, what are those? Web service, mail service, file service. Okay, now here is this guy want to access web request. How this guy will respond with the only web page? Because of here, before accessing anything, we need to mention the source and destination, MAC address, IP address. Okay, see, source MAC address what? A. Destination MAC address B. This is a source. This is what? Destination. What is the source IP? 1.1. What is the destination IP? What is the source port number? Now I want to open the web page. That means what is the port number for web page? 80. No. That means at my destination, I want to open which port number? 80. That means destination port number will be 80. Source port number? It could be anything from unreserved ports. Okay, anything from unreserved. Unreserved ports are what the range? 1024 to 65,535. No, these are what? Unreserved ports are open ports. Anything. Okay, let me define 1024. Who will assign this number? That number will be assigned by operating system. Okay, one more guys is MAC address C, IP address 1.3. Okay, you want to access same web request. Then what will happen? What is the source IP, source MAC address? C, destination B, source IP 1.3, destination IP 1.2, source port number. Okay, destination port number 80, source port number any number 1024. How it is possible? For this guy already done for 1024. For this guy 1025. For one more guy want to access, no, for him 1020. For one more guy it will go up to. That means how many users can access this server? Maximum 64K only from one network. From one network. Okay. Okay. All these guys are okay. So many guys are there. Okay. All these guys are belong to same network. Are all in the same one dot. Okay. There are some users that in the 2 dot network. They can also access this server. How many users can access? 64,000. Because how many open ports are there? 1024 to remaining all now. That means 64,000. Okay. This is all about guys. Okay. At destination, what port you want to open? Okay. Define that port number. Then server can understand. Oh, somebody is asking about the web request. Clear now, based on the port number only, it can identify the protocol. Then that protocol will open the web page. Clear now, based on the port number, that device can give the task to the protocol. Port number 80 means that is your duty. You have to open the web page. Then this guy will open the web page. Then only we can see here. Clear now? Okay. Any question up here? Clear now? All these port numbers write down. Almost 840, 50. Okay, no problem. And this is the port numbers for these things. And we have a TCP box and UDP and ICMP now. Who will carry all these boxes? No, boxes will be carried by IP layer. No, correct or not? IP. That means IP6 means IP will carry protocol number is 6. 6 for TCP. IP will carry protocol number is 17. 17 for UDP. IP will carry protocol number is 1. 1 for ICMP. These 3 boxes will be carried by IP. Every box will carry services. That you need to understand. Okay. Now ICMP, the box will carry 2 services, ping and trace. See, ping means there is full form is there packet internet group. For what the main purpose of ping and networking? To check the connectivity from where to where? Source to destination. This is my source, this is my destination. Both are connected directly. Whereas this is in this classroom CCNA, this is what? CCNP. Both are in different networks. I want to send some data. Before sending, I want to check the reachability from here to here. Reachability or connectivity. How to check? I want to give the ping. My IP address 1.1, my destination 1.2. I want to give the ping from where to where? 1.1 to 1.2. then automatically there are two packets will exchange from source to destination. One is called request packet, one is called reply packet. Clear? Who will carry this ping service, guys? That means here is a request packet now, that is called ICMP request. Reply packet will come now, that is called ICMP reply. Once you got the reply from so and so IP address, that means there is proper connectivity, there is proper reachability. Check it now. Let me go for CMD. Now I would like to give the ping with the google.com now. Just now before we given now google.com. Sorry, why I'm typing two times. Getting reply. That means there is proper reachability from here to Google server. Okay. Clear now? That reply means ICMP reply. And before that, what will go? ICMP a request packet will go. Then reply packet will come. Okay. Okay. These things don't ask now. This will discuss later. Okay. And trace is a utility to check the best routes from where to where, source to destination. This is my PC. This is my one more PC. And this PC is there in the Bangalore. This is there in the Hyderabad. Clear now? I want to check the reachability. From here to here, actually from data switch to router. Okay, connectivity. Okay, from data switch to router. Here also from data switch to router is there. Okay, from router to router, between which router, Bangalore to Hyderabad, there are multi links are there. One is Airtel, sorry, change the color. One is Airtel link, one is Tata link. Okay, you want to check the path. Which path? It is going via Airtel path or Tata path. How to check? By sitting here, you have to give the command called trace route and destination IP address is this, like a 10.1. You will come to know the data is going via Airtel or Tata. That means which path it is selecting. Imagine, and this is called 10 Mbps and this is called 20 Mbps. Okay, which is the best route? 20 Mbps. Okay, it is going via next address is so and so 1.2 like that. Okay, that means how to check the best routes or else how to check the path with the help of trace. Okay, now just now we discussed now destination ports will be always from reserved ports. Whatever the source ports will be always from open ports or unreserved ports. Clear now? Now write down these port numbers. Okay, and ping and trace, these also services. Ping for connectivity and trace for best routes. Okay. ICMP full form, anybody? No idea. Internet control message. Okay.
Okay.
Ping also full form is there. Packet internet grouper. Ping for to check the connectivity. Trace for to check the best routes and also to check the hops. Hops means from here to Google server, how many networks I need to crash. That means in between, how many routers are there. Okay, that information also given by trace route or else with the ping also will come to know. Anyway, if you give the ping with the google.com, you will get the reply from google.com. And also you will get the one number over there. That is called TTL number. Time to live. Based on that, by seeing the TTL number, we will come to know from your laptop to the google.com how many ops. That means how many ops away that server is available. Google.com. Ops means how many networks we need to crash to reach the google.com server. Start the section now. See guys, here I told now, if you give the ping command from this PC to and this PC. Why I was given the ping command to check the reachability. Okay. 1.1 to 1.2. What are the MAC address for this guy? A. How about this? B. If you give the ping space from where to where? 1.1 to 1.2. My destination is 1.2. Automatically what will happen? The packet will exchange. That means first one packet will exchange from where to where? From here to here. Correct now? That is called ICMP request. Then from here to here, ICMP reply. Correct now? While ICMP request time, see, you will receive the packet, okay? But which packet he receive? Whether he receive the TCP or UDP or ICMP, based on the protocol number. Okay, protocol number is what? 1. Before sending the ICMP request, it should mention my IP address is this, my MAC address is this, my destination IP address is this, MAC address is this. I am sending the which packet? ICMP. Protocol number will be 1, IP1. Okay, now I am sending the ICMP request or reply. For the purpose, I need to mention the type and code numbers. Mention what? Type and code. Okay, I am sending the ICMP request. While request time, type and code. Type will be 8, code number will be 0. Suppose I am sending the reply packet. That time type and code will be 00. Clear now? Reply will be always from where to where? Reply will be, this is called request box. Whatever this is what? ICMP request. Next is what? Request will be 1.1 to 1.2. Next is ICMP reply. Reply from where to where? 1.2 to 1.1. Now I need to add now 1.2 MAC address is B, 1.1 MAC address is A. I am sending the ICMP. That means protocol number will be 1. I am sending the reply packet. Type number and code number should be required 00. This is called ICMP reply box. Clear now? Write down all these things. ICMP request will be always from where to where? 1.1 to 1.2. Before sending the ICMP request, I need to mention my IP, my MAC address, destination IP, destination MAC address, and also I need to mention all these parameters. Okay. Protocol number for ICMP 1. Okay, this is a request box. A request means type and code will be type is 8, code is 0. While reply time, both will be 0. We need to mention based on that only device can understand. Suppose I received one information, I need to check the fast. This is which packet? ICMP or TCP or UDP based on the protocol number. Protocol number is 1 means TCP, sorry, ICMP. Whether I receive the request packet or reply packet based on the type and code. Type number is 8, code number 0. Reserved for a request. Reserved for ICMP request, guys. Type number, code number 0 for reserved for ICMP reply packet. Okay. Based recording, next slide. Okay, same thing only. Now we'll see the difference between, see actually between source to destination. Let me open the CMD. Because this is my device. Oh, sorry. Yeah, this is my PC. Okay. PC. Okay. And this is my switch. For the switch, I'm connected one PC. Switch will do what? Will maintain the MAC table. Na? Maintain the MAC table. Okay. That you know. But initially, what will happen? Initially, that table will be empty. That table will be empty. This will maintain the MAC table that is empty, and PC will maintain one table that is called ARP table. That is called what? ARP table. PC will maintain ARP table, and here also PC now will maintain what table? ARP table only. ARP means address resolution protocol. What your ARP protocol will do? It will figure out the destination MAC address with the help of destination IP. I know the 1.2, but I don't know the MAC address. Then how can I send the data? Before sending any data, I need to mention my IP address, my MAC address, my destination IP, my destination MAC address. But initially, I don't know about the 1.2 MAC address. Correct now? Then, with the help of ARP protocol only, we can able to figure out the destination MAC address. Okay. ARP request will be always broadcast. Okay. ARP packet will go to the switch. then automatically switch will forward to everybody. Okay. And this is called our table, address resolution protocol table, and this is called what? MAC table. What about this? Address resolution protocol table. And what are the entries will be there? Okay. And let me connect the connectivity first. Yeah. From here to here and here to here. See, this guy is connected. This guy MAC address is A, guys. What about this? B. IP address, 1.1. This is what? 1.2. And this A connected on the port number 1. Correct now? Via port number 1, switch port number 1, one PC connected. That is called MAC address A. Via port number 2, B connected. Actually, in the ARP table consists of destination IP and destination MAC address. Okay, what is the destination for me? 1.1, that MAC address is A. But a MAC table consists of what? Via port number 1, who is connected. Via port number 2, who is connected. But initially, all these tables will be empty. Okay, all the tables will be empty. What is the aging time for the MAC table? Aging time 300 minutes, sorry, seconds. That means 5 minutes. That means 5 minutes. Whatever the aging time for the ARP table? 4 hours. Okay, 4 hours. Okay, that you need to remember. Now, initially what will happen? All these entries are empty. All these entries are what? Empty, guys. Okay. I don't know about the 1.2 MAC address initially. Okay. Now, I want to send some data. I want to send some data. From where to where? This is the data I want to send. From where to where? Source IP 1.1. Source IP is what? 1.1. Okay, that MAC address is A. And destination IP 1.2. That MAC address I don't know. Into MAC. Okay, I don't know. Then can I forward this data? No, right? I can't forward. Correct? No, I can't forward. Okay. Let's say what will happen in this scenario. Okay, your ARP protocol will come into the picture. Address resolution protocol. It will send the one request packet. Who is 1.2? Could you please respond? That means what are the fields will be there in the ARP protocol? That we need to understand. ARP protocol contains these are the fields. Just now we discussed now in ICMP, we have a source and destination MAC address, IP address, and protocol number, type number, code number. Here also, okay, there are some fields will be there. First field is called source IP, source MAC, destination IP, destination MAC, and final one is opcode. Let me write on that also. Source IP, source MAC address, destination IP, destination MAC address, and opcode. Here is no type and code. Here is what? Opcode. While request time opcode number is 1, reply time 2. That you need to understand. Okay. Now opcode will be there. Okay. Now tell me guys, what is the source IP address? Yeah, request will be from always from where to where? 1.1 to 1.1 MAC address is A. 1.2 MAC address is no. How you will telling B? I don't know. Okay. That means I need to ask to everybody. That means when switch will ask to everybody, when switch will forward via port number 3, 4, 5, 6, 7, all. So many guys are connected now. It should ask to all the guys. When switch will do the broadcasting, okay, switch will check only layer 2 address. That is called source and destination MAC address only. Source is A, destination is FM. See, what is the broadcast address at layer 2? What is the broadcast address at layer 2 and at layer 3? At layer 2, the broadcast address is all F. How many Fs will be there? 1. How many hexadecimal number MAC address? Layer 2 means MAC address, no? That means how many hexadecimal MAC address? 12 hexadecimal. All 12 hexa numbers will be F. That's the last number now. F means what the binary for that F?
One.
1, 1, 1, 1. How many ones will be there? 48 ones will be there. Correct now? MAC address consists of what? How many bits? 48. All 48 bits are ones means that is called broadcast address in layer 2. That means this binary will be understood by missions, but we'll understand hexadecimal. That means all F means that is called broadcast address at layer 2. Clear now? Yeah, here I don't have a space. It is simply written 4 Fs. Okay. Clear now? What is the upward number for ARP request? 1 or 2? 1, right? 0x0001 actually. 0x0001. Okay. Now, forget about this one if you do not understand. Okay. Now, okay, shall I forward this ARP request from via this cable? Before for the data, I can't send from 1.1 to 1.2 because the 1.2 MAC address I don't know. Correct now? Now, in the ARP, all the fields are done, right? Any field is empty? No, no, right? Now I can able to forward. It will come to the switch port. What switch will do? Switch is a layer 2 device. We'll check the only layer 2 address. Source and destination MAC. MAC is a layer 2 address now. Source address is A. That is there in the MAC table. That is there or not? Not there, no. Then what switch will do? Switch will learn that source MAC address. What switch will do? Switch will learn the source MAC address is called. On which port number it is received? 1. Then destination MAC address what? Broadcast. That means sending. I need to forward via all the ports. We'll forward via port number 3, 4, 5, 6, 7, 8, 9, 10, and also via port number 2 also. It will come there. Correct now? Now what this guy will do? This guy will check the first destination MAC address and destination IP address. That means at layer 2, what is the MAC address? At layer 3, what is the IP address? Next is what is the opcode number? Okay, what is the source IP? What is the source MAC address? See there, destination MAC address what? What is the destination MAC address? All F now. That means that is for everybody. Broadcast packet. That means everybody. That is for everybody. That's for me also. Clear now? That is for me also. Then what is the destination IP? 1.2. Yes, I am the 1.2. That is for me. Okay. Okay, I received one packet. It could be TCP or UDP or ICMP or R protocol. For the purpose, I need to check the next information. Okay. Next is what? Opcode number. Actually, I need to check the source IP source MAC address. Coming from where? Coming from 1.1. That MAC address is A. That means I received one information from 1.1. What is that information? To check the next field, that is called opcode. Opcode number is 0x0001. 1 for opcode number 1 means this is called ARP request. That means I received the request, ARP request from 1.1. That MAC address A. Let me take these two entries, add over there. I received the ARP request from 1.1. That MAC address what? A. Getting now? Now, I received the request, but I need to do what? I need to send the ARP reply. Clear now? I need to send what? ARP reply. Let me create the ARP reply now. ARP reply from where to where, guys? Reply will be 1.2 to 1.1, 1.2 to 1.1. Source IP, source MAC address, destination IP, destination MAC address, and opcode. Yeah, source IP. See, reply is coming from where? 1.2. That MAC address? B. Destination is 1.1. That MAC address? Yeah, already entry is there in the ARP table. Opcode number 0x0002. Clear now? Now, I will forward this ARP reply. Then immediately, this is a layer 2 device now. We'll check only layer 2 information only. That is called MAC address only. Source MAC address is this. That is available in the MAC table. Available or not? No, right? I need to learn that one. I received on which port? port number 2. Now what is the destination MAC address? A. That is available on which port? Port number 1, sending from here to here. See there, ARP request is traveled via all the port. That means sending via all the port. That means ARP request will be always broadcast. What about this ARP reply? Port to port now. That means unicast. It will come there. What this guy will do? He will check the destination MAC, destination IP, and next is opcode number, source IP, source MAC address. Tell me guys, destination MAC address what? No, here. A means yes, I am the A. That is for me. And destination IP 1.1. Yes, I am the 1.1. That is for me. Next, opcode number 0x0002. That means I receive the ARP reply from 1.2. That MAC address B. Let me take these two entries, add over there. Now we are getting all the tables. Clear now? That means with the help of ARP request and reply only, all the tables will be formed. Then only I can take the destination MAC address. I will add over there. Correct now? Before what happened here? Destination MAC address is unknown, right? Now I can able to add the destination MAC address is 1.2. Sorry, B. For the destination MAC address, B now. Okay. Now I can forward this data. Clear now? Understand this one? Okay. Write down please what you understand. If you're getting anywhere confusion, ask me immediately. Question is required. Suppose you want to send the data from CCNA. In the CCNA department, we have some PCs are there. Okay, this PC, CCNA PC want to communicate CCNP department. That time what will happen? First, I need to send the packet to the router. That means I don't know about the router MAC address. Then can I forward the packet to the router? That time router MAC address will be discovered by our protocol. ARP request from here to router, then router to my PC, ARP reply. Then only original data will travel. Understand?
Oh, okay.
Yeah, like that. That here data means I will discuss about data means ICMP. Before sending the data, what I want to do? I want to check the reachability. Okay. For reachability purpose, I will do the ping. Okay, that ping process we'll see tomorrow. That is very, very important. Okay, that is very, very important ping process. Okay.
Okay.
When this ARP is very, very important. Okay. Why ARP request ARP packet will travel? Okay, if you go for any interview, if you have experience 3 years, 2 years, 10 years, without ARP resolution, no interview. Explain the, suppose you have experience around like 7 years. They will draw the very big topology will be there, like around like 10 networks or 15 networks. Explain the only ARP up to 3 hours in total topology. Okay. How ARP works from this end to this end. Between end to end, how many networks are there? It could be 15 or it could be 10. Okay, without stop continuously 3 hours. Okay, then only you will get the better package, minimum 12 lakhs per annum. Okay, that means monthly only. Minimum I'm talking about. Okay, maximum it will go 30 also. Okay, 35 also. They'll mention like a 12 to 18 lakhs. Some companies, okay, minimum will be 18 lakhs. Okay. Now we are discussing ARP resolution in same network only. We'll discuss about the ARP resolution from one network to another network also. Okay. But this ARP resolution is not there in the syllabus, guys. This is extra I'm teaching. Okay. OSA also not there. Only TCP UDP difference is there. Correct now? Okay. Now write down the written. Yeah. Next, let me open the document directly. Remaining stuff is there that we'll discuss tomorrow. OSI. This ping process we'll see now. Okay. Document. We have time now. Okay, let's discuss now itself. Data. I think where it is exactly. This document is newly created. Exactly where is that ping process? I don't know. Let me check one by one. It is not there here. Yes, and IP address also it won't be there. No. Internet technologies. No, I think in the first only. Yeah, this one. Yeah, this one. See, there are two pieces over there. Two pieces. This is called A. This is called B. For the IP address 1.1, this is a 1.2. Okay, this is a topology. In this topology, this PC connected on the port number 1. How about this port number 2? Correct now. Now, how the ARP table will form, how the MAC table will form. See, before sending data from A to B, or else 1.1 to 1.2, what I will do? I will check the reachability. Correct now. How to check the reachability? Ping, right? Okay. I will give the ping now. Ping with the destination is what? And ping will be carried by ICMP. Request packet will travel. Okay, what are the fields will be there in the ICMP request? Source IP, source MAC. Destination IP, destination MAC. Protocol number, type number, code number. Okay. Now, here is ARP table, right? Here is a ARP table. About here, MAC table. Initially empty now. I don't know about the 1.2 MAC address. See, source IP 1.1, MAC address A, destination 1.2, that MAC address, I don't know. Question mark. This is a which protocol? Protocol number 1 means ICMP box. Type number 8, code number 0 for ICMP request. Correct now. Now, can I forward this ICMP request via this cable or not? Can I forward or not? Huh? Who is telling? No. Why? Very good. We don't have a MAC address. Check it over there, guys. We don't have a MAC address. MAC address is there. Sorry. What is this? MAC address is there. Then what will happen? Initially, ICMP request will be dropped. Then who will figure out the destination MAC address? ARP now. ARP request will travel now. Source IP 1.1, MAC address A, destination IP 1.2, MAC address broadcast. Then upcode number for ARP request 0x0001. That packet will come there. Once the packet will reach to the switch, what switch will do? Switch is a layer 2 device. We'll check only layer 2 information. What is that? Source and destination MAC address only. Source MAC address is A. That is available in the MAC table? No, it will learn that A MAC address. Let me change the color also. It will learn the source MAC address on port number 1. Destination is broadcast. Sending via all the ports, via this port also. It will come there and it will learn the source IP coming from 1.1. That MAC address is A. Correct now? Then you will see the upcode number is 1. That means I receive the request packet from 1.1. I need to send the ARP reply. Reply from where to where? 1.2 to request will be 1.1 to 1.2. 1.2 MAC address what? So not 1.12. This one 1.2 only. Okay. MAC address B. Sorry, destination is 1.1. No, destination is 1.1. 1.1 MAC address A. Then upcode number for ARP reply 2. Once ARP reply will come here and switch will check the only source and destination MAC address only. Source MAC address is B, destination is A. B is available in the MAC table? No, it will learn that B MAC address. It will learn the B MAC address on which port? 2 no. Then destination is A, right? Available on which port? Port number 1 na. Directly sending from here. That means unicast. ARP reply is what? Unicast. ARP request is what? Broadcast. Clear now? Now that packet will come here and it will reach to here and they will check the, it is coming from where? Coming from 1.2. That MAC address what? B. Let me learn that one. Clear now? Now take the destination MAC address, add over there. Again ICMP will travel. Add the destination MAC address. Then send the ICMP request. Once ICMP request will come here. Okay, once ICMP request will come there, then what my switch will do? Switch will see the only source and destination MAC address. Source is what? A, destination is B. Both are available. B is available on port number 2 directly from here to here. Unicast or broadcast? Unicast. Then it will come there. What this guy will do? This guy will check the first destination MAC, that is called B for me. Destination IP 1.2, that is for me. And I receive the which information, check the protocol number is 1 means that is called ICMP receive. Whether request or reply, check the type and code. Type is 8, code is 0 means I receive the ICMP request from where? From 1.1. That means I need to send the ICMP reply to 1.1. That means ICMP request will be 1.1 to 1.2. Reply will be 1.2 to 1.1. Now 1.2 MAC address this, and for me destination is 1.1. That MAC address is A, and I'm sending the ICMP. Define the protocol number is 1. Then define the type and code for reply or request. Reply means 00. Then forward here and switch will check the only source and destination. MAC only, source is B, destination is A, available on port number 1 directly from here to here. Unicast or broadcast? Then it will come there and this guy will check the destination MAC, that is called A, that is for me. Destination AP 1.1, that is for me. And I receive the ICMP box based on the protocol number. Okay. And whether request or reply, I don't know. And check the type and code. Both are 0 means ICMP reply. Coming from where? 1.2. That means ICMP reply coming from 1.2. 1.2. Okay. Now we'll see all these things. Okay. See which is the broadcast here, only ARP request. Remaining all are what? Unicast. Clear now? All are what? Unicast. Now here what will happen? If your device is hub, it will do broadcast for all the packets. Check it over there. It will do broadcast for ARP request. See, for all the packets. ARP request and reply, ICMP request and reply, for all these things, it will do broadcast. What about the switch will do? It will do broadcast only for the ARP requests. Remaining all the packets, unicast. This is the answer in interview. Difference between hub and switch. This answer you have to tell. Okay, major. This is the important answer. Okay. They had to heard about the ARP. Then only they will come to know, you have some idea about the networking. Without ARP, okay, it is really your network is dead. Network is dead. That much important. Okay. Now write down, guys, this one. Here is some small mistake is there. What is that mistake? Request will be this. This is called 1.2. This is called 1.1. Okay. That is the only mistake. Okay. If you give the ping command, these are the packets will exchange. Initially dead, then ARP request, ARP reply. ICMP request, ICMP reply. Okay. See there. Okay, up to 5 minutes, shut down the PCs. Okay, shut down the PCs, then my MAC table entries will be gone.
Correct.
And ARP table entries will be there. Correct now, because the ARP table entries will be 4 hours. Okay, 1.2 MAC address is there. Here is 1.1 MAC address is there. Now, in this scenario, what will happen? That is the question. In this scenario, what will happen? That is the question. In this scenario, if you want to send any data from where to where? A to B, no? A to B. 1.1 to 1.2. All the entries are there now. Now I can able to send this data. Okay, data will come here. And switch will check the source and destination MAC address. Source is A, that is available. It's not there. It will learn. Destination is B, that is available here. No, it will send via all the ports. Now in this scenario, ARP request and reply will not happen. Only ICMP only, it will do what? Broadcast. That is called unknown unicast. Unknown unicast. That is unicast. This is unicast now. Because source and destination MAC entries are there, IP also there. That is unicast. But switch is telling I don't know. I don't know. I need to forward to everybody. If switch don't know, switch check the MAC entries. The entry is not available. It will do the broadcast. But this is not a ARP request. This is what? Original ICMP only. Okay. If you know the destination MAC address, simply add the destination MAC address here. Because the ARP entries are 4 hours now.
Right.
Only 5 minutes only I turn up the PCs. Still my entries will be there. Okay.
Okay. Got it.
That is called unknown unicast. Very, very important question. This question interview. In interview,
In that,
this is also one important question.
sir, in that case, if we'll remove the switch and add newly switch, then the scenario will be the same, right?
Scenario, yes, same to same, unknown unicast. That is unicast packet, but switch is telling I don't know what the destination MAC is. In my MAC entries, I don't have any B. Let's forward to all the ports. Let's forward to all the ports. That is called unknown unicast. What do you mean by unknown unicast? This is a question in interview. Okay. Actually, I forget. Write down. What do you mean by unknown unicast? What do you mean by unknown unicast? And one more question also write down, guys. In which scenarios switch will do broadcast? In which scenarios or in which cases switch will do broadcast? What is your answer? The switch will receive the ARP request, broadcast. If switch don't know about the destination MAC address, also broadcast. We don't have an entry in the MAC table, it will do broadcast. The switch will receive the ARP request, switch will do broadcast. If you don't have any entry in the MAC table, switch will do broadcast. One scenario. Second scenario, if the switch will receive the ARP request, anyway ARP request is nature is broadcast, it will do broadcast. My number, okay? Mobile number. Let me type the mobile number in the notepad.
Sir, just tell me, sir.
Yes, yes. See, 9502054634.
Okay, sir.
Okay, just ping me in the WhatsApp. I will share the link. Just click on that and you can able to join in the group. Okay.
Okay, sir.
Any question online, guys? Dipin and Ari, Bharat?
No,
No, sir. No, sir.
No question. Okay, guys, take care. I'll share this recorded section just in 1 hour. Okay. At 11 o'clock, you will receive. Okay. Right. Take care, guys. Bye bye.